In this video, we're going to discuss the SMV DS line of gamma cameras. This is the DST-XLi, the DSTi, the DSXi. They're all the same gantry. The difference is the configuration of detector size and number of detectors. My name is Eric Lay. I started with SMV, SOFA, SMV, in 1992, where I was the lead installation engineer, and later as GE purchased, I became the SMV installation specialist for the entire country, where I supervised, made sure that all SMV cameras installed under GE were properly installed and that they were prepared and completed correctly. I ended up being the owner of RES and the lead engineer here, where I continue to work on the same machines where we still install these SMV systems. What I'd like to give you here is a basic explanation of the machine. This is in a non-clinical environment. This is in our warehouse lab, and we'd like to go through a few things. We're going to describe the machine and the different phases you would see it in configurations for transportation and relocation. This camera has been assembled. As you can see here, we have the gantry. This is the gantry, which sits on the legs, which rolls on these rails. These are the detectors that are bolted onto the gantry. As you can see, it's a rather large machine. This is what we'd call an open gantry configuration or geometry. The majority of cameras out there are ring gantries, where you have a circular gantry and the patient goes through it. It's a little different. SMV was very innovative, where they were the first company to build the dual-headed variable angle cameras. Here we have one of the gantries that's partially assembled. You can see here the arms bolted on. These arms weigh 1,213 pounds, I believe. 1,226 pounds, actually, to be more exact. The gantry here, as you can see, this is a very beefy designed machine. They're just amazing. These things are tanks. They're built to last. They're very resilient. As you can see here, they took extra precaution to make sure these arms, these detectors, were bolted on to the gantry safely. There are 20 bolts holding each of these arms on. They're pretty hefty bolts. They're the hardened type bolts. 20, I think 4 would have done just fine, but they put 20 of them on there. As you can see, it's just a very well-built machine. Here we have a gantry that's been deinstalled from a clinical environment. It's wrapped up. But this is how the camera would arrive roughly from Buc when it was originally shipped from France. Buc was the city near Versailles. Once we uncrated it from the massive box that it came in, the wooden crates that these gantries were packed in were massive, and the supports were unreal. These things were meant to be shipped in sea containers and in airplanes all over the world. Most of the machines that came to the United States actually came through planes. So once we unpack the crate, it would come out. It would be on these dollies. These are original dollies that would be with this camera. The camera does not have the detectors attached. It would be too wide at this configuration. It is a little too wide to even fit into most cardiology offices. A lot of times we had to strip the hardware off to even get it to fit in. So this was as wide as the machine could be. These are the detectors. We call them arms. The detectors are in here. These weigh 1,226 pounds on the larger ones and slightly less for the cardiac configuration. This is not exactly how this would show up originally from the factory. These are on arm platforms. They allowed us to have a little more room to get in through narrow doorways. These were beefier than the original crates, which were too wide to fit in through your typical office door. As you can see here, these are about 4 feet long. They weigh 1,226 pounds. So together you had 2,500 pounds. So imagine, let's go through some physics here. So the logic is here, you could never have the detectors attached to this gantry because a couple things would happen. Physics would take over. First of all, the casters couldn't hold that, but it would immediately tip over. You'd crush the wheels, they'd tip over. It would not work. It's just not designed to do that. It's too wide, too long, too heavy. So there's a letter going around that suggests that these cameras, these gantries, could have been transported or relocated with the detectors attached. As I explained with these different machines, we've got a lot of physics to overcome for that to even be possible. And that's why we never did it. It just simply did not work that way. You've got a machine here that is 8 feet long almost, 4 feet wide. It weighs 5,314 pounds. That's not even counting the collimators here. This would be a big machine. The dollies would not work. You'd have dollies sitting back here. This machine would tip over. It just would not work. So the suggestion that these cameras were transported, relocated with the detectors on, as you can see, just doesn't make sense. It's something that has never happened. SMV, we never did it. We didn't do it at GE. And I hope I did a good job explaining this. Hopefully you made it all the way through this video. I appreciate your time, and thank you again.